Welcome back to the channel. My name is Vanessa, and today I'll be explaining pseudocode in a simple, beginner-friendly way. If you're new to programming and real code feels intimidating, pseudocode is one of the best tools you can learn early on. By the end of this video, you'll understand what pseudocode is, why we use it, and how to write it step by step. So, what exactly is pseudocode? Pseudocode is fake code written in plain English. It looks like code, but it's not a real programming language, and a computer cannot run it. Think of pseudocode as a plan or blueprint for a program. For example, it's like giving instructions to a chef for a meal or steps for assembling furniture before you grab the tools. It helps you focus on the logic without getting bogged down in syntax errors right away. Now, before we dive into coding stuff, let's see pseudocode in action with something simple, making instant coffee. On the slide, you have this pseudocode block. It starts with begin, then steps like put water in kettle, switch on kettle, wait until boiling, and so on, up to add sugar or milk if wanted, enjoy, and end. Notice how it's clear and sequential. Even if you're not a programmer, you can follow this. It's like writing a to-do list that's organized. This shows pseudocode isn't just for tech. It's for planning any task logically. Now let's talk about rules to make your pseudocode awesome. There's no one right way, but these tips keep it clear and easy to turn into real code later. First, use capital letters for keywords like if, else, for, begin, end. It makes them stand out. Second, one instruction per line, so it's not cluttered. Third, indent nested parts, like pushing in lines inside a loop or if statement, to show it's grouped together. Fourth, be specific. Don't say do stuff. Say exactly what, like add one to counter. And fifth, stay consistent. If you use an arrow for assigning values, don't switch to equals halfway. These are like grammar rules for your plan, making it readable for you or anyone else. The 5 building blocks of any program. No matter how fancy your code gets, it all comes down to these. Let's break them down one by one. 1. Variables, for storing info like little boxes holding data. 2. Assignment, putting values into those variables. 3. Input/output, getting data in from users or showing results out, like talking to the world. 4. Selection, making choices like if this then that. 5. Repetition, looping actions over and over. See how they're connected in the diagram. We'll explore each in the next slides. Focusing on the first 2 components here. Variables, think of them as named spots in the computer's memory to hold values. Use meaningful names like total_score instead of just X. It makes sense later. There's an icon showing total_score with 100 in it. Then assignment. This is putting a value into a variable, and it overwrites whatever was there before. For example, set x equals 5 means give x the value 5, not that x equals 5 like in math. The slide shows set score equals 100, and then set total equals total plus new underscore number, which updates the total by adding something new. It's like filling and refilling a jar. Input and output, how programs talk to users. Imagine a drive-through. You input your order, get output as your meal. On the left, input, getting data, using words like read, get, or input. Example, read username, grabs what the user types. On the right, output, showing stuff, with write, display, or print. Example, display welcome, username, prints a greeting with the name. This makes programs interactive, not just silent calculators. Now we're getting to the fun part, controlling how your program flows. First, selection, or making choices. This is if statements. If a condition is true, do this, else do that. The example shows if, condition, then statements, else alternatives, and if. Like deciding, if it's raining, take an umbrella. Else, don't. Second, repetition, looping, for repeating stuff. A while loop runs as long as a condition is true, with statements inside. Counters usually start at something, get checked, and increase. Example, while, condition, statements, and while. This is great for tasks like counting or checking lists multiple times. All right, now let's apply this. Our first real example. Read 2 numbers from a user, multiply them, and show the result. There are 2 styles, readable and short. Starting with the readable one, we begin with begin. Display a prompt like enter first number. then read num1. Same for second, display prompt, read num2. Then set product equals num1 asterisk num2, that's assignment. Finally, display the product is product, and it's detailed so you see every step. The short version, begin, read num1, read num2, product, num1 x num2, using arrow for consistency, print product, end. Simple, right? For beginners, try the readable style first. It helps visualize. The next example builds on choices. Check if a user's number isn't 5 or 6. Recommended style, begin, display, please enter a number. Read number. Then if number is not equal to 5 and not equal to 6, display the number you entered is not 5 or 6. Else display the number you entered is 5 or 6. End if end. It's like a yes/no question with two paths. Short style, begin, input number if number 5 and 6, output not 5 or 6, else it is 5 or 6, end if end. See how selection lets the program decide based on input. What if there are more choices? For this next example, assigns colors by number range. 0 to 10 blue, 11 to 20 red, 21 to 30 green, else error. Readable, begin, display prompt, read number. If number greater than equals 0 and less than equals 10, display blue. Else if greater than 10 and less than equals 20, red. Else if greater than 20 and less than equals 30, green. Else not a correct color option, end if end. It chains checks. Short, similar, but with input/output. Step by step, it evaluates one condition at a time until one matches. Time for loops. Print multiples of 5 from 1 to 100. Approach 1. Begin for counter equals 1 to 100. If counter mod 5 equals 0, then print counter, end if, end for, end. It checks every number. Approach 2. Begin for counter equals 5 to 100. Step 5. Print counter, end for, end. Skip straight to multiples. Both work, but step is smarter for efficiency. This combines everything. Count even numbers up to user limit. Begin, display, enter stopping point, input stop. Set count equals 0. For I from 2 to stop step 2, count equals count plus 1, end for. Output total even numbers found, count, end. Input for stop, assignment for count, repetition in the loop. Bigger task, read 5 numbers, average them, find min/max, show results. Problem broken into parts, a D, pseudocode, input in 1 to 5, sum in 1 plus and 2 plus and 3 plus and 4 plus and 5, ag, sum/5, min off them, max, print average, smallest, largest. It's a full plan. Expand min/max with comparisons if needed. Last slide. Pseudocode shines when you practice. Challenge. Check if number is even or odd. Solution. Begin, display prompt. Read number, if number mod 2 equals 0, display even, else odd, end if end. Now you try, sketch before coding, that's the end. Remember, pseudocode is your planning superpower.